Okay, in this video I'm going to be talking about two problems. Again, I'm going to have sub-intervals, and we're going to see what we did the other day where we had lower sums, and I'm going to use the same picture and I'm going to use upper sums. So the only two difference between these two problems is I'm going to do lower sums on this one and upper sums on the other one. I'm going to use the same sub-intervals, and then we're going to use equal width of 4. So what I'm going to do is I'm going to actually draw in those lower sums. So it looks like, since I'm just going from 0 to 4, that my width of each rectangle will be 1. So I'm going to go ahead and draw in the width of 1. And then what I'm going to do is, since I'm using lower sums, I want to make sure all my rectangles are below the curve. So notice if I draw from here to here, that would be above the curve. So I want to be below the curve. I want to be below the curve. I want to be below the curve and below the curve. This will allow me to find my lower sum. Now this is going to be a little bit more difficult to find because some of these aren't actual numbers. We'll end up with some square root answers. So we're going to be doing length times width again. Well, the length of this first one I can see is exactly 2. So we'll say the length is 2 and the width is 1. And my width will be 1 on all of these. The next one is the height of whatever this value is at 1. Okay, so when you plug in 1 in here, you get 1 plus 2 is 3. So the length is 3 and the width is 1. Plus this next one, there's actually a dot right here, but we don't know what that is. So we'd have to plug in 2 to be able to figure out what that is. So it would be the square root of 2 plus 2 times the width of 1 plus, then I'm going to plug in 3, so I know the height of this rectangle, which would be the square root of 3 plus 2 times the width of 1. This will give me an approximate area underneath the curve of 2 plus 3 plus 2 plus square root of 2 plus 2 plus square root of 3. So that gives me an approximate of, 5, that would be 9. 9 with all my whole numbers plus square root of 2 plus square root of 3. And if we really wanted to figure out what those are, we could bring up our calculator and we could see that the square root of 2 is approximately that, plus 3, the square root of 3, plus 9 equals approximately 12.15, approximately 12.15. The next one, the last example here, is just the upper sums. And the upper sums, we're going to have sub-intervals of 4 again. So I'm going to draw in 4 rectangle spots. I've got 4 spots. This time I'm doing upper sums, so I want my curve to be above, or my rectangles to be above the curve. Not very straight there. So the area would be approximately the length times the width. So the length of this first one is what I get when I plug in 1. So when I plug in 1, I get a height of 3, or a length of 3, times the width of 1, plus whatever I get when I plug in 2, which would be the square root of 2 plus 2, times the width of 1, plus this next rectangle's the height at 3, so the square root of 3 plus 2 times 1, plus what the height is here at 4. Square root of 4, the square root of 4 is 2. Okay, so square root of 4 is 2. 2 plus 2 is 4. So I have a height of 4 times 1. So my approximate area under the curve would be 3 plus 2 plus square root of 2 plus 2 plus square root of 3 plus 4. So I end up with 5, 6, 7, 8, 9, 10, 11, approximately 11, plus the square root of 2 plus the square root of 3. So we can use our calculator again to come up with a decimal. So we'd have 11 plus 2, the square root of 2 plus the square root of 3 equals 14.15. 14.15. So the last approximation was 12.15, and this approximation is 14.15. So maybe we'd say the actual area under the curve is about 13.15. We still don't really know because these are just approximate area underneath the curves.